we are given here a graph of a function that is defined by y equals rx. We don't have an explicit expression here. So, and the domain of this function is from -3 to 3, and the range is from, oops, sorry about that, and the range is from 0 to 4. Okay, now what we are going to do is that we are going to discuss various transformation of the graph of this function. Now we would like to sketch graph of the function that is given by this equation, y equals r of x minus 1. What we did was that we changed x to x minus 1, and if you remember, what this transformation does is that it horizontally shifts the graph to the right by how many units? 1 units. And let's go ahead and look at that transformation via computer. So this is a graph of y equals rx, and we are going to graph the function given by y equals r of x minus 1. And what we are expecting is that this graph will shift to the right by 1 unit. So let's see what it does, and very soon I'll write an example in which we will do it a little more actively. Okay, so let's give it a different color. Okay, and when we do that, indeed the graph shifted to the right by how many units? 1 unit. Okay, so now with this transformation, the domain of the new function becomes what? That becomes from, that becomes the closed interval -2 to 4, and the range is, the range again, range is the same because in the horizontal shift, the y values didn't change. So the range still remains what? From the closed interval from 0 to 4. Okay. Now in this attempt, we are going to look at a graph of the function given by the equation y equals r of x plus 1. That is, we are changing x to x plus 1. And what happens in this case, that we will expect a shift to which way? This is plus 1. So shift it to the left by how many units? 1 unit. Okay. So here we go again. So I am asking this package to graph the function given by y equals r of x plus 1, and I am, let's choose a different color here. And if you look at that, the black graph, it did shift to the left by how many units? 1 unit. So look at this transformation, and again you shall notice that we have, for the transformed function, the domain, the closed interval from -4 to 2, and the range still stays from 0 to 4. Okay, so that is the domain of the transformed function is -4 to 2, and the range is from 0 to 4. Okay, now we will look at some other transformations. Okay, now we will see the transformations when we look at graph obtained by the equation y equals r of 2x. All right, so in this case, what we would expect is that we are really attaining the y values much faster now. That is, we will expect this graph to shrink. All right, and that shrinking depends on this factor, as you are going to see in the transformation. So I'm going to write in here r2x, and let's give it a different color. Okay, let's keep it red. And as we expected, Now the graph shrank, okay, by the factor of 2, all right, with domain of what? From the closed interval negative 1.5 to positive 1.5, and the range is still remaining as closed interval from 0 to 4. Okay, in this case, we are going to look at a graph obtained by this equation, y equals r of x over 2. So now, we will be achieving those y values at a slower rate, and in this case what will happen? This graph will horizontally stretch. Okay, so let's enter that in here and see what we get. Okay, so we have x over 2. Okay, all right, and as we expected, the domain of this function is the closed interval from negative 6 to 6, and again we did only horizontal stretching, so shifting so far, so the range remained the same, that is the closed interval from 0 to 4. Now in this case, we are going to discuss graph of a function given by y equals twice rx. That is, for any given x value, the y value obtained from this equation will become what? Twice that much. So what we will expect here? We will expect that this graph is going to stretch vertically by this factor. So let's go ahead and observe it. So we will add this item, that is instead of y equals rx, we have twice rx here, and we'll change the color just to see the distinction. And of course, the new graph has done what? Has vertically stretched this graph, taking twice the y value for any given x value for this. So the domain of this function remains the same as that of the original graph, that is the closed interval from negative 3 to 3, but the range has become what? Double in this case, that is the closed interval from 0 to 8. Now if we have to look at a graph of this function, in this case what I have done is, or what we have done is, that is, instead of y equals twice rx, we have taken y equals 2 times r of rx and minus 3. That is, every y value is going to go down by how many units? 3 units. So we are going to see a vertical downshift in this red graph by how many units? 3 units. So let's go ahead and observe that. So we will do this. We got 2 rx, okay, as the red graph, and then we're going to subtract 3 here, and let's take the color blue in this case. And what happens now? That this red graph shifted down by 3 units. So now again the domain still remains the same as the closed interval from negative 3 to 3, but the range changes, and the range is what? The closed interval from negative 3 to how much? 5. Okay. Now we are going to look at another example. Here we have graph of a function defined by y equals hx, and the domain is negative 2 to infinity, and the range is from 0 to 1. Now just to understand the shifting, we are labeling some convenient points on the graph of this function as shown in this picture. This is negative 2, 0, the x-intercept, and this is the max here, which looks like 2, 1, and this is 5 and approximately 0.5, and we are going to look at different transformations. So now using this graph, which is given by the equation y equals hx, we would like to graph the function that's defined by y equals h of x minus 1. So in this case, what we are going to expect? We are going to expect a horizontal shift to the right by 1 unit. So during the course of that horizontal shift, negative 2, 0 will horizontally shift by 1 to negative 1, 0. 2, 1 will shift to the right horizontally by 1 unit. So it's going to land at 3, 1, and 5 and 0.5 will switch to 6 and 0.5. So which gives our new graph as this red graph, okay, passing through these three shifted points, okay. And then when it comes to writing the domain and range, we have the domain from the interval from negative 1, including negative 1, all the way to infinity, and the range is the closed interval 0 to 1. Now we would look at the transformation that is given by y equals h of x plus 1. In this case, we will have a horizontal shift to the left by 1 unit, and the new graph should look like this red graph is starting at negative 3, 0 here, and the domain will be all real numbers greater than or equal to negative 3, or the interval is starting at negative 3 going all the way to the infinity, and the range remains the same, that is from 0 to 1. Now here we are changing the equation from y equals h of x to y equals h of 2x. So we will have horizontal shrinking. Negative 2, 0 will change to negative 1, 0, 2, 1, that will correspond to 1, 1, and the new graph will look like the domain is all the real numbers, negative 1 and larger, or oh, here there is a, yeah, this looks awful. 1 second. So it should be what? I'm sorry about that. Okay. I mean, I can't really include infinity, can I? Okay. So here you go. So the domain is the closed interval negative 1. Again, I made a mistake, too late in the evening. So domain is the interval starting at negative 1, including negative 1, and going all the way to infinity, and the range is the closed interval 0, 1. Okay. Now see, we have to look at the transformation result obtained by changing hx to this expression, that is, or changing the equation to y equals twice h of x minus 3. So what will happen in that case is this. Let's look at twice hx. Every y value has become 2 times, for each x, every y value will be 2 times the y value corresponding to this black graph. And then when we subtract 3 from every y value, this red graph will shift down by how many units? 3 units here. Okay. And the domain is still what? Negative 2 to infinity. I mean, including negative 2. And the range becomes what? Because of this shifting downwards, the lowest point is negative 3, and the highest is, for the closed interval, negative 1 here. All right.